Hi students, the subject we are discussing is groundwater development and management, and the topic is aerial photogrammetry. Okay, yeah. Before going to discuss about aerial photogrammetry, we have to know about this photogrammetry. Okay, what is photogrammetry? Okay, simple terms. The first term is photo, another one is grammetry. The term itself defines the measurements. Okay, by looking after a photograph and measuring the land or whatever the respective site we have given, that one. Okay, photogrammetry. You can simply see here, the photogrammetry is the science of making measurements from photographs. The input of photogrammetry is simply the photographs and the output is the map. Here you can see these are all some typical pictures of this aerial photogrammetry. From the top view, that means from the helicopter also, we simply click some photographs and we measure this land from that photographs. Okay, if we do different we can either measure 2D models as well as 3D models. Okay, if we take a single photograph, we can measure only a 2D model. If you take some lappings between the photographs, we can eject them as 3D models. Okay, right. Okay, what is the use of photogrammetry? These are all the uses. These are all the fields in which we actually use photogrammetry. Those are simply topographical mapping, the first thing. Okay, we take the inputs of photographs and we create maps, right? Architectural, in the field of architecture as well, we use photogrammetry. In the field of engineering, manufacturing, quality control, police investigations, right? By using these drones and all, nowadays the police are even working on this, right? In the lockdown, they are using drone cameras and searching for any culprits over there. Okay, and cultural heritages, geology, of course, architecture, archaeologists also use this photogrammetry, and if there exists any meteorologists also use this to check the tornado speeds and all. Okay, right. Even this photogrammetry also uses in the automobile industry for the collision engineering, right? And even in shootings, post-production works, in creating what we say, graphics, graphical imaginary. Okay, clear? Right. Why we actually use this photogrammetry? Okay, it is actually more cheaper than your terrestrial methods. If you go on survey the entire area using any auto level or so, there will be a lot of time consuming, right? Okay, this photogrammetry is simply very precise as well as time and cost effective, cheaper than your terrestrial models, as well as uses less manpower and more accurate. The algorithms it will be tested with based on well tested algorithms, so it is very much accurate. Geographical fidelity, that means entire area can be covered by this photogrammetry. Qualitative information can be taken out, and map generation is map generation can be done at a quicker rate, right? So if you wanted to calculate normally, if you wanted to generate normally maps, it will take a lot of time. So if we use this photogrammetry, we simply can lap 2 photographs or 3 photographs and create a map accordingly. Okay, right. How many types of photogrammetries are there? How many types of photogrammetry we are using, right? Okay, the first one is close range, terrestrial, aerial, and space. Okay, close range is nothing but which we can actually opt to see very nearer distances. Terrestrial is nothing but from the surface of ground itself, any place higher than your object, your site, we can select that site and we can take the photographs and all. Aerial, by using helicopters, planes, all those from mounted cameras can be used and required photographs can be taken. Another one, space. This is simply the space, it's nothing but we use satellite data. Okay, right. We can either differentiate them based on their meter distances. Okay, if it is closed range, the distance is nearer to 10 meters. Beyond 10 meters, we can't like tell that it is closed range. Okay, if you are dealing the photographs from a range of 10 meters to 100 meters, then we call it as terrestrial. If we are taking the distance from the camera is about from 2 meters to 10 kilometers range, 2 kilometers to 10 kilometers range, then we can call it as aerial photography. Beyond 30 kilometers range, all the photographies we are taking or can be called as named as space photogrammetry. Okay, right. Yeah, this is one of the example of close range photography. We can see it is very closer range, the image is very clear. Okay, of course, if you are taking the ground based cameras and the position and orientation can be measured, means we can say it as terrestrial photography. We opt a place where entire site is visible and we place that camera on that place and we simply click the photographs, right? This is how the aerial photogrammetry can be done by by the means of any aircraft, either flight, helicopter or any other jet. And space photogrammetry, I said in the earlier, extraterrestrial photographs are space based. Okay, from the satellites, we can simply click on the photographs. From that photographs we can all these photographs will be available with Geological Survey of India, right? From them we can simply get the data out. We can check out any information we want. We can turn them into maps, whatever necessary things. Okay, right. This is actual topic, aerial photography. Aerial photogrammetry is nothing but by using aeroplanes. That is what we have discussed in the earlier, right? So the photographs taken from aeroplane in regular intervals at definite height from ground level. Okay, with a definite height, we have already discussed it ranges between 2 kilometers to 30 kilometers. All this distance will from the ground, right? That distance taken from a definite height. Okay, in a regular intervals. So you can see from here from the plane we have mounted a camera and taking out the photographs. Here we are using drone and we are actually taking photographs of the site. Okay, yeah. Now this is how we actually plan and execute a aerial photograph. This is actually an important question. Before going on to aerial photography, what are the factors we need? What are the parameters we have to consider? Okay, these are all the parameters we have to consider. The first one is need and purpose of photography. Okay, in the foremost consideration made in planning and execution of aerial photography, the photos of super quality are required for the tropical mapping. So that is why we have to select a particular purpose. What is the purpose we are actually choosing? Topographical mapping, we use a superior quality cameras. For any other needs, we just alter the needs of the camera. Okay, next one is scale. You all know that scale is nothing but simply saying Of course, the photo scale for topographical mapping depends upon the final map scale. Okay, if you are actually doing a scaling of 1:100, the picture like the map looks somewhat different. If you are using a scale of 1:50, the map looks a little different, right? So we have to consider that one as well, that parameter as well. If you are considering if you are planning for a aerial photography, the scale of photography is also has to be considered based on your required scale of your map. Okay, that means if we want a 1 meter precise length or a 1 kilometer precise length, that matters. Okay, the next one is side lapse. Okay, if you wanted to know about the side lapse, I'll just show you the picture first. Okay, this is called side lapse. If two aircrafts are side by side and taking photographs, that lapping zone is called as side lapse. If a camera, like if a single craft is carrying a camera and taking a side by side photographs, if there is two cameras taking side by side photographs, then we consider that lap gap is called as side gap. If a single camera is taking two photographs, that we consider as end lap. If in this case the lap should be there, like should be allowed is 30%. In this particular end lap thing, the lap should be maintained is 30%. Sorry, 60% minimum. Okay, now you can see requirement for photogrammetric control extension. Side lap required for photographic control extension and topographic mapping is about 30%. If it is less than 30%, that won't give you an accurate map. It won't give you a perfect map. Okay, the side lap should be minimum of 30%. If we are discussing about end lap, that requirement, that extension requirement for topographical mapping is about 60%. If it is less than 60%, we can't figure out a perfect map. Okay, the next one is height of flying. The height of flying is also a very important parameter. The height of flying also gives you what we say, the accurate the height of flying for a project can be evaluated after the selection of camera and the scale of photography. The scale and the height of flying are almost vice versa. These if the flying height is increased, the scale will decrease. Okay, if the flying height is decreased, the scale will increase. Okay, then the ground coverage can have to be taken into consideration. Whatever the amount of area we are actually surveying, we are actually choosing, all the ground coverage can have to be taken into consideration. And seasons also very important. The altitude of sun, fallen leaves from the trees intact, all these parameters taken into thing. Okay, if it is summer season, there will be a altitude of sun is a bit different and the sunlight will be different, and so that the photographic images and pixels and everything will be different. So based on the season also, it is a little different. And weather conditions also very much important. If there is extensive wind, that won't give you, if there is a cloudy day, that won't give you a clear picture. If it is having a humid atmosphere, that won't give you a clear picture. So all those weather conditions also matters, so we have to consider that one as well, right? And the last one is flight map. The flight map is prepared depending on the considerations and specifications which are mentioned all the above. Okay, all the above parameters will be considered to check out this flight map. The flight maps are prepared to obtain the project boundaries, flight lines, and the pilot must fly so as to require the aspired coverage. The flight map will be designed so that all the above needs to be covered. Okay, that is also a very important factor, right? Next slide. Classification of aerial photographs. Aerial photographs are mainly classified into vertical and oblique. Of course, we know that vertical is nothing but straight from the top, right? From if it is making a 90 degrees angle, the axis of camera is making a 90 degrees angle, then we call it as vertical. If the angle is other than 90, if we purposefully tilt the angle, that is called oblique. Okay. Yeah, here we can see the photographs are mainly divided into terrestrial as well as aerial. Okay, terrestrial is nothing but if we do a photograph from close range, and as well as terrestrial photogrammetry, those photographs are called as terrestrial photographs. That means the photographs which are captured from the ground itself. If the photographs are captured from the aerial view, that is from aircraftals or space, then we call them as aerial photographs. Aerial photographs are again divided into vertical and oblique. Vertical, oblique and oblique. And then vertical again divided into true and tilted. True vertical and tilted. Oblique or high oblique and low oblique. Okay, we'll just discuss in brief in the next slides. Okay. This is what the vertical photograph is. Vertical photographs is the one where the axis of camera is truly vertical. In some cases, the axis of camera may not be exactly vertical. Tilting of axis may appear. If at all we are calling that photographs as vertical photographs, that tilt range is allowed only at the rate of 1 degree to 3 degree. Okay, if the tilt is only up to 1 degree and 1 degree to 3 degree, then we can call it as vertical photograph. And in this, true is nothing but exactly 90 degrees. True vertical is exactly 90 degrees. Tilted is somehow a little tilt is allowed. Okay, this is what the aerial photograph looks. This is the plane position, your camera position. Okay, its axis. If the axis is exactly 90 degrees to the ground, then we can call it as vertical photograph. Okay, the next one is oblique. Oblique is simply, we have discussed in the earlier, right? If at all the angle is anyway greater than or less than 90 degrees, then we can call it as oblique. Okay, if the axis of camera is purposefully tilted from 90 degrees inclination, then we can call them as oblique photographs. That is again divided into two. One is high oblique, another one is low oblique. High oblique is the one the axis is tilted such that the horizon is appeared, then we call it as high oblique. If the horizon is not appeared, then we can call it as low oblique. What is this horizon? We just see in the pictures. Okay, right. This is what we call it as origin. This line. Okay, if the camera line is exactly coinciding to the area where we have to take the photograph, right? The entire land, this is the area covered. If there is no extra spacing, if there is no extras going on, right, this is called origin. If this origin is appeared, then we call it as high oblique. If there is no origin, we call it as low oblique photography. Okay, up to here we have discussed about all those, what is photogrammetry and why we have to use photogrammetry, the uses, in that different types of photogrammetries, aerial, space, terrestrial and close range, right? What is the what are all these meanings, all those definitions? Clearly our topic is aerial photogrammetry. We have discussed what is aerial photogrammetry, what we use, from that how many types of photographs are there. If you are taking from aerial view, how the photograph is looking, like how it shows up, right? If it shows up exactly vertical, we call them as vertical photographs. If it is tilted tilted other than the inclination of 90, we call them as oblique. In that, all the different types. If the oblique also, there's two different, the oblique and oblique. All these have been covered in today's topic. And in the next topic of photogrammetry, we discuss that aerial photography application in the field of groundwater subsurface investigations. Okay, the case we will take a small case study or so. We'll discuss how this aerial photography is, like the procedure of aerial photography is involved in subsurface investigations of groundwater, right? So we just discuss all the topic in our next class. Okay, keep studying, take up the notes, study well. Okay, all the best, carry on.